before there were stars, before there were planets, before there was anything you could point to and call something. The universe was just a fog, a warm, dark, almost perfectly smooth fog, stretching in every direction for hundreds of millions of light years, almost perfectly smooth. That tiny word, almost, is the reason you exist. That word is the reason every star in the night sky exists. Because in the earliest moments after the Big Bang, the universe wasn't completely uniform. There were microscopic wrinkles, quantum ripples, places where matter was 100,000th% denser than everywhere else. 100,000th%. And from that, almost nothing, everything was born. Every galaxy you've ever seen in a Hubble image, the swirling spirals, the glowing ellipticals, the chaotic, irregular masses of 100 billion stars. They all trace their origins back to fluctuations smaller than an atom. This is how galaxies form. Now here's where physics becomes the most dramatic force in the universe. Not nuclear explosions, not gamma ray bursts, just gravity. Quiet, patient, absolutely relentless gravity. Those tiny, overdense regions we just talked about, they had fractionally more mass than their surroundings. And mass pulls. It pulls on the gas nearby, which makes it denser, which pulls harder, which pulls more gas. The process is self-reinforcing. Physicists call it gravitational collapse. And once it starts, nothing stops it. But there's a twist. The early universe was also expanding, fast. So gravity wasn't just quietly gathering matter, it was in a race against the expansion of space-time itself. In some regions, gravity lost. The gas was stretched out before it could clump. But in the densest patches, those precious overdense ripples, gravity won. And when gravity wins, it wins spectacularly. Think of it this way. Imagine dropping a single drop of food colouring into a spinning bowl of water. It doesn't fall straight down. It spirals. It stretches into filaments. It clumps in some places and thins in others. That's almost exactly what dark matter, the invisible scaffolding of the universe, was doing on cosmic scales. Collapsing, spinning and threading itself into an enormous web. Astronomers call it the cosmic web, and it's the skeleton every galaxy has ever grown on. Inside these dark matter halos, these invisible gravitational wells, hydrogen gas was accumulating, getting denser, getting hotter, getting compressed. And somewhere around 100 to 200 million years after the Big Bang, something happened that no camera has ever captured because no camera existed to see it. The first star in the universe switched on. We call this era the cosmic dawn, and those first stars, astronomers call them population 3 stars, were nothing like the stars we know today. They were enormous, hundreds, perhaps thousands of times more massive than our sun. They burned so hot and so bright that they were almost pure blue-white fury. They would have outshone entire modern galaxies, and they lived for only a few million years before dying in catastrophic supernovae. But those deaths mattered enormously, because those first stars were made almost entirely of hydrogen and helium, the only elements that existed at the time. When they exploded, they seeded the surrounding gas with the first heavy elements, carbon, oxygen, silicon, iron. They polluted the early universe, and thank goodness they did, because without that pollution, no rocky planets could form, no water, no chemistry complex enough for life. Every atom of calcium in your bones, every atom of iron in your blood, it was forged inside a star and scattered by a supernova. probably many supernovae. You are, in the most literal scientific sense, assembled from the wreckage of the universe's first generation of stars. Here's where the story gets violent. Early galaxies weren't born fully formed. The first proto-galaxies were tiny, irregular, chaotic clumps, thousands or tens of thousands of light years across, not the grand spirals and ellipticals we see today. They were messy, turbulent, saturated with star formation happening so rapidly that astronomers today call those early objects star-burst galaxies. And then they started smashing into each other. The early universe was more compact than it is today. Everything was closer together. Galactic collisions weren't rare catastrophes. They were routine. Two proto-galaxies would spiral toward each other, drawn by gravity, distort into wild tidal streams and merge. Their stars almost never actually collide. The distances between individual stars are so vast. But the gas clouds absolutely do crash together, triggering new waves of star formation. Larger structures ate smaller ones. Over hundreds of millions of years, through merger after merger, the small became the large. This process, called hierarchical structure formation, is essentially how a galaxy like the Milky Way assembled itself. Our galaxy has consumed dozens of smaller satellite galaxies over its lifetime. Right now, it's in the process of slowly devouring the Sagittarius dwarf galaxy, cosmic cannibalism running quietly on billion-year timescales. And here's the haunting part. The Milky Way itself is on a collision course with Andromeda, our nearest large galactic neighbor. In about 4.5 billion years, the two galaxies will begin to merge. The collision will take hundreds of millions of years and will completely reshape both galaxies. Our solar system will almost certainly survive. Individual stars are too far apart to collide. But the galaxy we live in will be unrecognizable. Astronomers have already simulated it. They've already seen what it will look like. Look at any deep field Hubble image and you'll notice something immediately. Not all galaxies look the same. Some are elegant spirals with sweeping arms. Some are smooth, featureless spheres of aging stars. Some are irregular blobs that look like nothing in particular. Why? The answer lies in their histories. Spiral galaxies, like our own Milky Way, are the survivors. They've accumulated mass gradually, through relatively orderly mergers and steady gas infall. They still have lots of cold gas available to form new stars. The rotating disk, the spiral arms, these are signatures of an ordered rotation that was preserved over billions of years. Elliptical galaxies, by contrast, are the results of major, violent mergers. When two large spiral galaxies of similar size collide head-on, the ordered rotation of both is destroyed. Stars are flung into random orbits. The resulting merger product is a smooth, round blob, an elliptical, with almost no cold gas left and therefore almost no new star formation. Ellipticals are often called red and dead by astronomers because they're dominated by old red stars and making almost none new. Irregular galaxies are often galaxies in the middle of being disrupted, either by a collision or by the gravitational influence of a massive neighbor. The large and small Magellanic Clouds, visible from Earth's southern hemisphere, are classic examples. They're being tidally stretched and distorted right now by the Milky Way's gravity. Shape, in this sense, is biography. A galaxy's form tells you its story. There's something we've been dancing around this entire time, something that never appears in any photograph of any galaxy. but without which no galaxy could exist. Dark matter. We don't know what it is. We've never directly detected a single dark matter particle, but we know it's there because of what it does. Galaxies rotate in ways they shouldn't. If only the visible matter were present, the outer stars of a spiral galaxy would fly off into space. But they don't. Something invisible is holding them in. Something with gravity, but without light. Dark matter makes up roughly 27% of the universe. All the stars, planets, gas, dust, everything you can see with any telescope ever built, makes up only 5%. And the cosmic web we described earlier? That's a dark matter web. The filaments, the nodes, the vast walls and voids of the large-scale universe, they're all made of dark matter, with ordinary matter clinging to it like frost on wire. Galaxies don't just form in dark matter halos. They are dark matter halos, with a thin, luminous shell of gas and stars visible on the surface. When you look at the Milky Way on a clear night, you're seeing perhaps 1/6 of its actual gravitational extent. The rest is invisible, stretching far beyond the visible disk. We built everything we know about galaxy formation on top of a foundation we cannot see. Here's what makes galaxy formation one of the most exciting frontiers in all of science. We still don't fully understand it. We have excellent models. Simulations like Illustris TNG can generate synthetic universes that look remarkably like the real one. But those simulations have to make assumptions about how supermassive black holes at galaxy centers influence their host galaxies, about when and how star formation turns off, about what exactly dark matter is made of. And the James Webb Space Telescope has already started breaking our models. In its first year of operation, Webb detected galaxies that shouldn't exist according to our best theories, galaxies that appear to be too massive, too structured, too mature to have formed in the time available after the Big Bang. Astronomers are genuinely baffled. Either these galaxies formed in ways we don't understand, or our estimates of their distances are wrong, or, and this is the exciting possibility, there is something fundamentally incomplete in our picture of how the early universe worked. Every new telescope generation reveals that the universe is more complex, more surprising, more creative than our models assumed. We have answered the question of how galaxies form, but the answer keeps revealing deeper questions beneath it. That, perhaps, is the most human thing about cosmology. Every time we see further, we discover there's further still to see. The next time you look up at the night sky, past the light pollution, past the atmosphere, out toward those faint smudges of light that aren't stars, you're looking at galaxies, each one containing anywhere from 1 million to 1 trillion stars, each one built from invisible scaffolding, forged through violence and collision, seeded by the first stars that ever burned. And you, standing there looking up, are made of the same story. The iron in your blood, the oxygen in your lungs, the carbon your body is built from, all of it arrived here via supernovae, via the long chain of cosmic violence and creation that began with a quantum ripple smaller than a single atom. The universe didn't just form galaxies, it formed a way to look at itself.